geometric sequence. In the first example, the question is asking us to identify a geometric sequence. In the past, we've talked about an arithmetic sequence. With our arithmetic sequence, we found that between each number in the sequence, we had a common difference. The difference between an arithmetic sequence and a geometric sequence is that in a geometric sequence, there is a constant ratio between each consecutive term, and that ratio is called the common ratio and is identified by the letter R. We need to identify that common ratio, so we're going to look at this second column, which is our a sub n column. Remember from arithmetic sequences that n represents the position of the sequence, so position 1, position 2, position 3. It has to be a number that is a natural number. It cannot be 0, and it cannot be irrational or decimal. And then the value of the term is the second column. So if we look at the relationship between the consecutive numbers, you'll notice that we are multiplying by 3 to get from one term in the sequence to the next term in the sequence. This question is asking us to define a recursive formula for the sequence. A recursive formula means that it has to use the value of the preceding term in the equation to find the subsequent term. So in this case, when n is equal to 1, a sub 1 is equal to 4, and with the r value being 3, that's our common ratio. If we want to come up with a definition for the recursive, we could say that the second term is really taking that first term and multiplying it by 3. So let's put this all together and make a recursive definition for the sequence. So we start with a sub n, which represents any term. And it kind of looks like a piecewise function, where we put the value of the first term in the upper row, and that's when n is equal to 1. And then we put our definition in the second row, and that's for when n is greater than 1. Now, to finish this off, we just need to input our values for a sub 1 and our definition. So the value for a sub 1 is the value of the first term, which is 4, and our definition is 3 times the value of the preceding term. And how we write that is a sub n minus 1. So I'm going to write that over here. A sub n minus 1 is equal to the value of the preceding term. So here is our final answer. In question 2, we're asked to translate between the recursive definition, which is what we're given in this question, and the explicit definition. As a reminder, the recursive is used when you have the value of the preceding term. That is the only way you can use the recursive. The explicit means that we can come up with an equation that we can find the value for any term. So if we want to find the 22nd term, we sub in n is equal to 22. If we want to find the 4,000th term, we sub in n is equal to 4,000. So the explicit definition is that is more commonly used. You need a formula for your geometric sequence in the explicit form. So here is your formula. It's a sub n is equal to a sub 1, so the value of the first term, times the ratio raised to the exponent of n minus 1. Now let's identify what information is given to us in the question. The 5, The 5 is the value of the first term. A sub 1 is equal to 5. The 1/2 is the r value. So we're actually given the pieces of the formula that we need to put it together. A sub n is equal to 5 times 1/2 to the n minus 1. It's not that challenging, but you have to understand the way that the recursive formula is set up in order to pull the appropriate information from it. In example 3, we are asked to solve problems of geometric sequences. So in this example, we have a phone tree where one person calls a certain number of people, then those people each call the same number of people, and so on and so forth. In the 5th round of calls, 243 people were called. So we're talking about rounds of calls. So let's put our explicit form together, and we identify what we know. The first round, 3 people were called. And in the 5th round, 243 people were called. Now, the diagram is a little bit confusing, but I did double check the textbook. They do want us to use that the first round starts with 3 people, not the one person. So that's why I have a sub 1 is equal to 3. What we don't know is r, but we can use the explicit formula to find r. So we're going to plug in what we know. We know that a sub 1 is equal to 3. We do not know r, so we'll leave that as a variable. And then we do have a value for n. When n is equal to 5, a sub n is 243. So I'm going to plug a 5 in here and put 243 on the left-hand side. Now we have a formula with one variable, so we can simplify and solve. I'm going to start by dividing both sides by 3. So we end up getting 81 on the left-hand side and r raised to the exponent 4 on the right-hand side. So we end up getting 81 on the left-hand side and r raised to the exponent 4. To remove that exponent, we're going to raise both sides to the power of 1/4. The right-hand side will simplify to equal 1, and the left-hand side will simplify to equal 3. Putting it all together, we have 3, which is our a sub 1, times 3, again, which is our r, to the n minus 1. And this is our explicit formula that we can use to identify the number of people called in any round. So when we're asked to find out how many people were called in the 8th round, we can use that formula we just derived. So we plug in when n is equal to 8 and simplify. So we have 3 times 3 to the 7th. And remember, this has to be simplified first, and we end up getting 6,561 people called in the 8th round.